In this video, we will be exploring Docker volumes. Docker volumes are a way to manage persistent data storage in Docker containers. Let's dive in to understand what exactly Docker volumes are. One of the key challenges when working with Docker containers is the ephemeral nature of data. When a container stops or is removed, any data stored within the container's file system is lost. This can be problematic when you need to persist data across container restarts or share data between different containers. Here's an example. First, we run an Ubuntu container in interactive mode using the command docker run-it ubuntu bash. Inside the container, we create a file named data.txt and write some important data to it. Then we exit the container. Unfortunately, when the container is stopped, the data inside data.txt is gone forever. Docker volumes provide a solution to the data persistence problem. A Docker volume is a persistent storage mechanism that exists outside the container lifecycle. This means that data stored in a volume will not be deleted when the container is stopped or removed. Docker volumes offer several key features. First, data survives container removal, ensuring that your important information is not lost. Second, volumes can be shared between multiple containers, enabling data sharing and collaboration. Third, volumes typically offer better performance than bind mounts, which are another way to persist data in Docker. Finally, Docker manages volumes, simplifying the process of creating, managing, and backing up your data. Docker offers three main types of storage mechanisms: volumes, bind mounts, and temporary file system mounts. Volumes are Docker-managed storage areas that reside outside the container's file system. This means that Docker is responsible for creating and managing the volume, and the data within the volume persists even if the container is deleted. Bind mounts, on the other hand, directly map a directory or file on the host machine to a directory within the container. This allows you to share files and directories between the host and the container, but it also means that the container has direct access to the host file system. Temporary file system mounts, also known as tmpfs mounts, create temporary storage within the host's memory. This type of storage is ideal for sensitive data that you don't want to persist on disk, as the data is automatically deleted when the container stops. There are two primary methods for creating Docker volumes. The first method involves explicitly creating a volume using the docker volume create command. For example, docker volume create my-data. This command creates a named volume called my-data, which can then be used by one or more containers. The second method is auto-creation. This happens when you specify a volume when running a container. If the volume does not exist, Docker will automatically create it. For example, the command docker run-v my-data:/app/datanginx will create a volume named my-data if it doesn't already exist, and mount it to the /app/data directory inside the Nginx container. To use volumes in containers, you need to understand the basic syntax for mounting a volume to a container. The syntax is as follows: -v volume_name: container_path. Here, volume_name refers to the name of the volume you want to mount, and container_path refers to the directory inside the container where you want to mount the volume. For example, the command docker run-v my-data:/app/datanginx mounts the volume named my-data to the /app/data directory inside the Nginx container. As a practical example, consider running the MySQL database with persistent storage using a Docker volume. You can use the following command: docker run-d \v mysql-var/lib/mysql8.0. This command runs a MySQL 8.0 container in detached mode and mounts the volume named mysql-data to the /var/lib/mysql directory inside the container, ensuring that the database data is persisted even if the container is stopped or removed. Docker provides several commands for managing volumes. To list all existing volumes, you can use the Docker volume list command. This command will display a list of all volumes on your system, including their names and drivers. To view detailed information about a specific volume, you can use the Docker volume inspect command followed by the volume name. For example, Docker volume inspect my-data. This command will provide information such as the volume's creation date, mount point, and options. To remove an unused volume, you can use the Docker volume remove command followed by the volume name. For example, Docker volume remove my-data. This command will delete the specified volume, freeing up disk space. Docker also provides commands for cleaning up unused volumes. To remove all unused volumes, you can use the Docker volume prune command. This command will identify and remove any volumes that are not currently in use by any containers. For a more complete cleanup, including volumes, you can use the Docker system prune-volumes command. This command will remove all unused containers, networks, images, and volumes, freeing up a significant amount of disk space. When working with Docker volumes, it's important to follow some best practices to ensure data integrity and efficient management. First, use named volumes over anonymous ones. Named volumes make it easier to identify and manage your data, while anonymous volumes can be difficult to track. Second, store data in dedicated directories within the container. This helps to organize your data and makes it easier to back up and restore. Third, perform regular cleanup with the volume prune command to remove unused volumes and free up disk space. Finally, back up your important volume data to prevent data loss in case of unforeseen circumstances. In summary, Docker volumes provide persistent, shareable storage that survives the container lifecycle, making them an essential tool for managing data in Docker environments. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.